Guys, please quiet. Now. Guys, look at this. Everyone please listen. Now today we have two tasks to do, learn. The first task is that we are going to solve a typical problem like that, which involves, we are still focusing the importance of the unit circle in localizing the events which happens in the universe, but now we just move away a little bit and work the trigonometry on the right triangle. And in the right triangle, we just solve this one together. However, at the end of this, you take a quick break, then we start a very important part, which is trigonometry in 3 dimensions. It's absolutely easy if you learn how to deal with a right triangle in 2 dimensions. It's absolutely easy. Then please, I'm gonna review the key terms, the key things that we learned yesterday, and since the beginning of the trigonometry, then as we move on to JM, to the 3 dimensions trigonometry, you see, oh my God, look at that. Everything is so easy. Now, the thing that we learned, I should say, sorry, what? Of course, please do so. Give me this one? Yeah, awesome. Yes, please. The thing that we did, and we covered yesterday, we said that when we see that we have a mixture of the right triangles and geometric shapes, that we are interested to find either the length or the angle, the only thing that we have to do is that we just deal with the problem, we attack the problem one geometric shape at a time. Then don't let it confuses you. The first thing that we have to do, we just pretend out of these 2 geometric shapes, 2 right triangles, there is only one. Then when we deal with the first one, we just go to the second one. The easiest one we can think is going to be which one? Which triangle you think that's going to be the best one to start with? The left one. The left one, fantastic. I mean that if we look at the left one, we see that, Caitlin, we see that we have a right triangle. We have one of them. It has an angle which is 45 degrees. And the other one is also 45 degrees. What kind of triangle is this? And what is the property of that? The 2 lengths are equal, yes? And it's apparently, without even doing any geometry or any trigonometry, we can see that, okay, P, this one is going to be what? 15 units. I say units because we do not know the dimensions, the unit of the dimensions, either meter or centimeter. That's the first one. And the second one which we can do is this. We see that, okay, we are talking about the R, the hypotenuse. You know that the hypotenuse is what? We said that the R squared, based on the Pythagorean theorem, R squared is equal to the length, each one is squared, which means that once we have 15 squared plus the other one, which is 15 squared. R squared equals to what? How much is 15 times 15? How much? 225. Look at that. It's 2. That's fantastic. Fantastic. 225 plus 225. Then as a result, we get R squared equals to how much? This is plus, huh? 450. And now we can find the inference that R is plus or minus square root of 450, which is how much? For 50, it becomes around 21. Fantastic. That's brilliant.
Okay.
That's right.
But am I allowed to do this?
Of course. Yes, great job there. Fantastic. Very, very smart. And then as a result, we got R equals to what? 21 point, let's round it up 21. Now the R is 21 units, and now we just move on to the next part. Let's pick up this color. Now we got R as 21. Hi Jackson. I have given the test result. I'm just going to give it back to you during the break that we're going to take in the next 10 minutes. Now, as you see that out of these two geometric shapes, one of them is built, the first one. Now we just move on to the second one. We see that the other one is a right triangle, which makes working with the geometric and trigonometric ratio much easier. Now look at this. This is the second type of the geometric shape that we are interested in. The right triangles, which they come either 45 degrees or 30 and 60 degrees, because we know that this one is going to be 60 degrees. We are looking to find the values of the Q and T. In order to find the value of the Q, we use the basic definition of the geometric, where is the reverse? The trigonometric ratio. What is the definition of, guys? What is the definition of, we see that here, we are looking for, let's say, for example, R, we know R, we are looking, for example, for the value of the Q. If you look at this, Q is just the opposite length with respect to the 30 degrees. Then the first thing which you can think of is that in one of the ratios that I'm familiar with, I know that the definition and the recipe for the sine of an angle, it says that it's going to be the ratio of, let's say, for example, the opposite angle over the hypotenuse. But if I do that, I see that, look at the trick here. I say that if I take sine of 30 degrees, which equals to how much? Huh? Guys, always look at that. Carry your calculator in case, if you cannot just, I should say, use this one, the best and easy way to do that is just use the calculator. And if you use that, it becomes 1/2. And you see that also you have the inverse of the trigonometric ratio is there, which we're going to use that just in 2 seconds. Okay, now you see that the sine of 30, we take it if as 1/2, then we say that, okay, the definition of the sine is what? The opposite over the hypotenuse. The opposite is Q, but the hypotenuse is T equals to 1/2. You see that here, it's not going to be very helpful because the thing that we have over there, we says that it's the opposite over the adjacent, sorry, opposite over the hypotenuse. It gives me Q over T. And as you notice here, you see that now we have two coefficients that we do not know how much is that. Previously, it was so easy because if I knew how much is the hypotenuse, it was easy to find the value of the Q. Now I do not know even how much is the hypotenuse and no Q. And what do you think is the best strategy to use? Or tangent. That's right. Because what is the definition of the tangent? Exactly. We said that the definition of the tangent is the opposite length over the adjacent, which we have Q over R. But how much is the R? We got it a couple of seconds ago. That's right. Then as a result, tangent of 30. Then as a result, we say that tangent of 30 equals, we do not know how much is the Q, we leave it there, but we know how much is the R is 21. Put that in your calculator. How much is tangent of 30? 1 over 2 over the square root of 3 over 2. How much do you get? Tangent of 30. 1 over 2 over square root of 3 over 2. It becomes 1 over 2 over square root of 3 over 2 becomes square root of 3 over 3 equals to Q over 21. So far is good, everyone? Yes? Now, look at this. The only thing that now we have to deal with this is to find the value of the Q, and the rest of the thing is just the numerical values. And what can we do? Yes? Oh, you mean this one here? Because look at this. Compare. Okay, look at this. I'm gonna name it 1. I'm gonna name it 2. Look at this. Ask a very good question. That one I didn't use the sine of 30 in order to find the Q. I have two expressions here. Expression 1 and expression 2. Look at this one. If I use sine 30, I have the opposite over hypotenuse, which is Q over T equals to 1 over 2, because sine 30 is a very popular ratio. But look at this Ash. I'm looking for the Q, but I'm stuck with the number of T. Then I see, oh, I have one number, 2 parameters, which they are not now. That is impossible.
I was looking at the triangle the wrong way.
That's right. Now, but as I should say, Lawrence said, if I use tangent, I have opposite over the adjacent. Adjacent is the R, and I keep it 21, and I find the value for the Q. Does it make sense?
Yeah.
Now, then as a result, what is the value of the Q? Q equals to, H2 goes all the way to this one, becomes, I should say, 1. Then we have 21 over square root of 3, which you can rationalize it or normalize it by multiplying that by square root of 3 over 3, which it takes you what? 21 square root of 3 over 3, which eventually becomes 7 square root of 3. And gonna be, that's the value for the Q. Yes.
I don't understand why you have 1/2 divided by 3 over 3.
For the definition of the tangent, sine over cosine.
Yeah.
You mean here?
Yeah.
This is the sine of 30, and this is the cosine of 30.
Oh, okay. And then you got what in the end? Sorry.
We got then Q over 21. Then this one, look at this. I multiply both sides by 21. And these two, they cancel out. I have the square root of 3 left. Then I rationalize it by multiplying both sides to the square root of 3 over 3. And now, look at this one, guys. Maybe that's going to be the question of some of you. Look at this. How did I simplify this expression? It's 1 over 2. It multiplies to the inverse of the one which we have here. Which you see that 2 and 2 cancel out, and I have square root of 3 instead. I multiply 21 to both sides, then I have 21 over the square root of 3. Then I rationalize it. Does it make sense to everyone? How did I get from here to here? Because this one is essentially 1 over the square root of 3. You multiply both sides to 21, you have 21 over the square root of 3. But you rationalize it by multiplying both sides to the square root of 3. Does it make sense to everyone? Captain, are you sure? Awesome. Priyash, Russell, everyone, Jaya, Rishabh, Faithful. Yes? Awesome. Now, we are almost towards the end, then we take a 1 minute break, then we just start the three-dimensional trigonometry. And now we have one more thing left, which is t, the hypotenuse. Life can't be easier for the t because we can use for the t, what we can use, look at that. We have a right triangle, which it says that t squared equals q squared plus r squared. Pythagorean theorem, nothing new. Then as a result, we have t equals to square root of, how much is q? Q 7 times become the 7. No, let me write it in a very bare way. Where is my eraser? I'm gonna solve it here. Okay, look at this. What is going to be t? Let me start by t squared. We said that t squared equals q squared. What is q? We got here q. 7 times square root of 3 to the power 2 plus. What is r squared? That's right, 21 squared. Now look at this, guys. And Medina, look at this. Now for this, I'm gonna take square root of 2, not square root of 2, exponent 2 inside this now. I know that 2 comes as an exponent for all of these two things because they are multiplied. Am I right? Then as a result, what do I get? I get, it becomes 49, that's right, multiplies into square root of 3 to the power 2, which is 9, square root becomes 3, plus 21 to the power 2. It's simplified as to 49 times 3 plus 21 times 2. And guys, the rest of it is for maybe 2 years ago. And for the rest of it, I'm not going to do this. You simply add them together, take the square root to get the value.
4, 1.
Okay. $49 times 3 becomes how much? 147 plus 21 times 2. That's right, fantastic. And the addition becomes how much? That's right. And t equals to what? Let me take this. 5, 5, 8. It comes around to 23. Approximately, it's 23. Then as a result, you see that t becomes around 23. Let's put that 23.7. Now, 24. Let's round it. That's I love that idea to round it to 24. It's better than 24. Roughly to 24. Now, does it make sense to everyone? What did I do so far? I didn't use anything except I consecutively used the definition of the basic trigonometric ratio. What is the sine definition? What is the cosine? And but above all, if I didn't know the ratio, the trigonometric ratio for 30, 60, and 45, which they are the fundamental things, I always stop. I cannot do it. And that's the key point to take. If you see to the test, deal with them one at a time. Yes.
Would this be a no calc question or a calc?
Both of them. There are two papers.
But like for this question specifically?
For this one,
Could this be considered
with calculator.
with calc?
That's right. Oh, sorry. No. This one without the calculator. Because in that going to be easy then to just find that. Now, guys, any questions? If you do not have any questions, we are taking, I should say, 3 minutes break. When we come back, we are dealing with the three-dimensional stuff. And Jackson, I have your paper. To just focus. Guys, look at this. If you remember all the things that we did right down here, and if I move on to this slide, then you see that, okay, this is a box in 3 dimensions, but there is no difference at all between what we have done in the past and also what we are going to do right now. The task that we want to do is that, look at this one. Look at the, let me pick up a color. I think black is good. The task that we have to do is this. Look at this. We have a box. It comes with 3 basic dimensions. The AB is 6 centimeter. We have BC, which is 3 centimeter. And also we have FG, which is 2 centimeter. Now, what we want to do is that we just say that we just want to find the angle, which is here. You see, the task that we have to do, is that, look at this, I should say, pink colored triangle. This is called angle of the elevation. We are just going to find how much is the alpha just by knowing the length of this box. Now, just look at it. Just take 30 seconds to reflect on it and find if you think of any way to solve it. We have still 31 minutes before the class ends. You may wonder, all the things that you see here, guys, everyone please look at this. The thing which I'm going to say is essentially the building blocks of what we are going to do. When you look at these problems like that, what do you expect to see? You see all over the place the right triangles. This is a right triangle. Let me look at this. This is a right triangle with the length 3 and 6. And also ACF also is a right triangle with the angle is 90 here. Look at this. You see that the thing that we have here, the angle is 90 degrees. Now, in order to find the alpha, you see that the alpha comes as a right triangle which is confined inside this box. Then the best thing that we can always say is that we say that with this box, we know all the dimensions, but how about if we find the dimensions of this right triangle which is confined inside the box? What is that right triangle? I mean this triangle. This is A, C, F. And our focus now is that to focus our attention to find everything that we can find about the length, about the angles of this right triangle. Now, how to do that? I have a very strong tool. That's Pythagorean theory. Why? Because look at this. My first task is this. What is the length of, I know what this is AB. What is the length of AC? I mean, what is the length of AC? You see that in order to find the length of AC, we can look at this triangle. For this triangle, Look at this. I know that in this triangle, AC is the hypotenuse of the triangle ABC. Then we say that in triangle ABC, because AC is the hypotenuse, what is the length of BC? Of course, 2. Thank you. Because this is parallel to the FG. Then we say that. Then as a result, AC to the power 2 plus AB to the power 2 should give me what? Should give me it should not. It should be AB to the power 2 plus BC. Sorry, my mistake, because I was looking for the AC. We say AB plus BC. Then BC. Sorry, guys, I just made a mistake over there. It's BC, this length, which is 2 squared, plus AB, this length, which is 6 squared. It gives me AC squared. I know what is the BC. How much is the BC? 2. Then I have 2 to the power 2 plus, how much is AB? 6. 6 to the power 2 gives me the length of AC squared. Then I have 4 plus 32, 36 becomes AC squared. Then as a result, you see that AC is how much? 40. Because 36 plus 4 becomes the square root of 40 for the AC. Then you see that this length, which is AC, becomes now, guys, and now we find the length of the AC, because our focus, as I said, guys, please quiet. Because as I said, the focus is triangle ACF. Now we find the length of AC. What is left for the triangle ACF to find? That's right. Also, we have the length of the CF. How much is CF? That's right. It is 3. And what is the length of AF in case? That's right. Another Pythagorean theory. We said that in the ACF, we say that the AF squared equals to what? Equals to AC squared plus FC squared. Am I right? Now, AF squared, we are looking for it. But AC is how much? Square root of 40. Then we say square root of 40 raised to the power 2. How much is FC? That's right, 3 to the power 2, 9. Then AF equals square root of 40 raised to the power 2. How much is that? 40 plus 9. Then we say AF equals how much? That's right, 7 centimeters. Then now we have AF as 7. Guys, please quiet. Rihanna. Now, guys, now we know whatever we need to know about this right triangle, which is the triangle which is confined inside this box, which is ACF. We measure the length of the FC, which is 3, which is parallel to GB. We got the length of AC, which is the square root of 40 from this part. And we got the hypotenuse, which is AF, from this part, which is 7. Our task is now going to solve. Oh my God, I gave the test result. It's at the end of the class. I'll give you a
Oh,
awesome. Now we are looking for the alpha. That's all you just solve in this problem. Guys, now, in order to find the alpha, everyone please listen here. Because this type of the problem is the one that you have to use your calculator. And if it shows up on the test, you need your calculator. And listen because of two things. First of all, you understand the logic. And second of all, understand how to use your calculator. Look at this. Now we have all these three lengths. We can find all of those basic fundamental trigonometric ratios. We have the opposite length, we have the adjacent, we have the hypotenuse. Which, for example, we can think of the sinus. The sine of the alpha. The definition is that if alpha is looking towards this direction, he's seeing the length FC as the opposite, and it finds FA as hypotenuse. Then as a result, what are we gonna have? Please listen very carefully from here. Then we say that I'm gonna start it from here. We say that the sine of alpha as a definition becomes the opposite over the hypotenuse, which is 3/7. Now, you can choose any other thing. You can find the cosine, you can find the tangent, cotangent, secant, or cosecant. I just use the sine. You can just choose any other thing. And the task is this. What is the value of the alpha? How to find this? That's right. We said that in order to find it, alpha becomes sine inverse of. That's right. You have had that concept before level 3, huh? Inverse. Now, then how much is the alpha?
25.
Everyone knows how to use a calculator for it?
65.
How much should you get? 25. Then we say alpha. I trust that you just did it on your calculator. This is being recorded, otherwise that's embarrassment for me. Then we said that alpha is 25 degrees. Then you see, when it comes to the three-dimensional shape, it's incredibly easy to always work in the right triangles. In any 3 dimensions, you find just the right triangle, and we use the same basic things that we have for. Yes.
You also use I don't know how you say it in English, but there's a law of angles that are out
oh,
In town, out town?
I don't know, like the angle of the triangle that we solved for would be equal to the same angle next to the right angle triangle.
Oh, it becomes purely geometric then.
Yeah.
Then we can also use that, but the purpose was that we just use with the trigonometric ratio. Otherwise, on the test, there is no mark for it because the purpose is that to use this definition. Please be careful, just use these basic ones. But that one is also correct. But if you use that on the test, they see, because they break down the marks for each part, they see nothing is there. Please be careful, guys. Just use trigonometry. But that's a good point. Now, the last one, which I'm gonna solve, is this. Any questions on this, guys? Anyone? No? The next one, I'm gonna ask you to do it yourself. But remember, on those two things which I posted on the Google Classroom, there is plenty of these ones with the answers, the detailed answers. Now, we're gonna do this together. I'm gonna give you a first hint, then you work on it, and before we leave, I'll solve that for you. Now, look at this one. I wonder if you can find this angle. Look at this right triangle. Find the angle, which is here.
Are we assuming the bottom is a square?
That's right. Everything is a square, guys. It means that this length also is 4 centimeter. The task is that how much is the alpha? I'm gonna stop the recording and just move on to deal with the one which is on the Google Classroom. The first thing that we have to do is this. That look at this. If this is a square, it means that this angle is definitely is 90. Then it means that the hypotenuse, guys, please, everyone quiet. Look at this. Then it means that this hypotenuse, for this I should say right triangle at the base of this pyramid is how much? I mean AC. AC squared equals to AD squared plus DC squared. I do not know what is the AC squared. It becomes 4 to the power 2 plus 4 to the power 2. It becomes how much? 32. Then AC is how much? Square root of 32. That's what I wanted. For the hypotenuse of the base of the right triangle. However, guys, if you look into that, you see that we are in this triangle that we have, because our care is this triangle. The triangle that we have, which is located at the, let's say, call it V, O, C. That's a triangle. Then as a result, we are not looking for the whole length of the AC. We are looking for the OC. But in geometry, you can prove that the length of the OC is equal to half of the length of the AC. We are not going to prove that geometrically because we are going to use just the result. Then as a result, the length of the OC is square root of 32 over 2, right? Now, then we have this length, square root of 32 over 2. And we have also this length, which is 3. I mean, the length of the VO is 3. We are looking then for the alpha. What is the alpha? We can see that the alpha is just looking at this length, and also we have its adjacent length. We used it before. The tangent ratio is the best one, which describes this. Then as a result, what can I say? I say that we say that the tangent of alpha equals to what? The opposite, which is 3 over square root of 32 divided by 2. Then I get tangent of the alpha. Look at this one. We have 2 here. Means that when you just want to rewrite it, it comes all the way up. You flip it, it converts it to the multiplication. We have 2 square root of 32, which essentially becomes equals to 6 over square root of 32. You can rationalize it by multiplying that both to a square root of 32, square root of 32. Then you get tangent of the alpha is how much? 6 over square root of 32 over 32, which roughly equals to
46.
around 46. Did you have a calculator?
Yeah. 46.68.
Are you sure? 46. Let me check it myself. It seems to me a little bit odd.
Would this be paper 1 or paper 2 question?
Paper 2.
Okay, so we can use a calculator.
That's right.
Yeah.
46, huh?
Oh. Yeah.
Guys, I got a very different answer. Yes. Look at this. You get the square root of 32, which is 5.6.
Maybe if you divide that by 2. You only have to turn it. Yeah.
And look at this. It becomes a 5.65. You can multiply to 6. You get 33.9. And you divide it by 32. It gives you 1.05. We call it roughly at 1.6. Oh, no, you mean the angle, the inverse. I just meant the tangent of the alpha.
Oh.
Look at this. I said, oh my God, it's impossible to get the tangent that big. Now, then as a result, what did we do? We said that the tangent of the alpha, let me go to the next page. We said that the tangent of the alpha is equal to 1.6. Then the alpha can be taken as tangent inverse of 1.6, which how much did you get? 45?
Yeah.
46.6.
40.6. Let's call it 40.6 degrees then. Then as a result, you go back all the way here. You see that now, by using this one, we were able to find the angle in this three-dimensional shape. Or also you can have written it like that also. Without going all the way to that direction, you could have said the alpha is tangent inverse of 6 square root of 32 over 32 equals 46 degrees. Okay. Fantastic, not fantastic. Okay, now, any questions, guys?
No.
If you have no questions, then